algorithms, the divide and conquer ones. Let's start with merge sort. This sounds different.
It is quite different. Merge sort is a classic example of the divide and conquer paradigm.
Divide and conquer.
Uh,
Break it down.
sure. The idea is if you have a big problem, break it into smaller, easier to solve subproblems, solve those, and then combine their solutions to solve the original big problem.
How does that apply to sorting?
With merge sort, the divide step is simple. Take your unsorted list and split it into two roughly equal halves.
Okay, just cut it in the middle.
Yep. And then you do the same thing to each of those halves, split them. And you keep doing this recursively
Until
you have sublists that contain only one element.
and a list with one element is...
Already sorted. That's the base case, the trivial subproblem.
Okay, so we've divided down to sorted singletons. Now the conquer part.
The conquer part is the merge step. You take two of these small sorted sublists, initially the single element ones, and you merge them together to create a single larger sorted sublist.
How does the merge actually work?
You look at the first element of each of the two sorted sublists you're merging. You pick the smaller of the two, put it into a new temporary
And then what about the other list?
Whatever is left in the other list is guaranteed to be sorted and larger than everything you've already put in the results. You just append all its remaining elements to the end of your result list.
Okay, so that merge step produces a larger sorted list from two smaller sorted lists.
Correct. And you recursively apply this merging process. You merge sorted pairs into sorted fours into sorted eights, and so on, until you've merged everything back into one single fully sorted list.
The notes outline this with merge a sort array and merge array 1 array 2 functions.
Right. Merge a sort array checks if the array size is greater than 1. If yes, it divides it, recursively calls merge sort on both halves, and then calls merge to combine the two sorted results.
And merge array 1, array 2 does that careful comparison and building of the new sorted array we just talked about.
Precisely. Using pointers or indices to track progress through array 1 and array 2 and building the merged result.
The visual walkthrough is 6745, 2314, 633, 9842 is really powerful here. You see it break all the way down.
Do individual numbers.
And then build back up, merging 45 and 67 into 45 and 67, 14 and 23 into 14, 23, and so on.
Exactly. It shows the recursive calls dividing and the merge operations combining things back in sorted order at each level.
And the C++ code snippets for merge and merge sort show this recursion and the temporary array often needed for merging.
Yes, the merge function typically needs that auxiliary space to store the merged result as it's being built before copying it back if needed.
Where does merge sort excel? What are its main applications?
Merge sort's big advantage is its guaranteed performance. Its time complexity is O(n) log n in all cases, best, average, and worst.
Unlike bubble or insertion or even selection sort, that's reliable.
Very reliable. This makes it great for sorting large data sets. It's also excellent for external sorting where data is too big for memory and lives on disk.
Why external sorting?
Because the merge step can work well with data streams coming from disk. You can read chunks, sort them in memory, maybe using merge sort itself, write them back, and then merge the sorted chunks.
Clever. What else?
It's used for counting inversions. It's stable, which is crucial for algorithms like timsort used in Python, Java, Swift libraries. It works well on linked lists where random access is slow. And it's easily parallelizable. You can sort the halves and merge parts concurrently.
Plus, the merge operation itself is useful, like for finding unions or intersections of sorted lists.
Absolutely.
So advantages and disadvantages overall.
Advantages: stable sort, guaranteed O(n) log n time. Relatively simple concept, naturally parallel. Disadvantages: usually requires extra memory, O(n) auxiliary space for the merge steps, so it's not in place. Sometimes slightly slower in practice than quicksort on typical data due to this memory usage and cache effects.
Okay, that sets up our next one nicely. Quicksort, another